Identifying outliers in a multi-level model with R. If you run a multi-level model or linear mixed effects model, it is important to check whether you have outliers in your data. Hi, my name is Arndt Riegosch. I'm a statistical consultant, and in this video I will show you how to identify outliers in a multi-level model with R on both levels. Because that is the key challenge with a multi-level model, that you have to check your modeling assumptions on more than one level. First we have to estimate our model. Here I use the nlme package, but the code I'm going to show you for outlier detection works with both main mixed effects packages in R, nlme and nlme. This is an inbuilt dataset in the nlme package I'm using, analyzing the effect of sleep deprivation on reaction time. So it's a longitudinal dataset, but the outlier check I'll be showing you works just the same with the cross-sectional multi-level model. After some data cleaning, I set up the multi-level model. Reaction time is predicted by days, so we have one fixed slope, and as random effects we have a random intercept and a random slope for days. And here with the random effects we can see we have three random effects. Level 1 the residuals, and on level 2 random intercept and random slope for days. And for those three we will check for outliers. For the outlier diagnostics I'll be using the nlme package, and I'll be showing you two types of outlier analyses. We'll be looking at Cook's distance and we'll be looking at box plots of the residuals. And these analyses will be performed on both levels, on level 1 and on level 2. First, Cook's distance. For that you can use the nlme influence function. Here is the fit object of our multi-level model, and level equals 1. Here we get a data frame with the different influence measures, and here is the column for Cook's distance. To see whether there are extreme cases, let's look at the extreme values for Cook's distance using the summary function. And the maximum value is 0.07. Is this high? There are different cutoff points discussed for Cook's distance. One possible value is 4 over n, with n being the number of observations. Here we have 180 observations, so 4 over 180 gives us 0.022. At least the highest Cook's distance is above this cutoff, so it would make sense to now analyze Cook's distance for observations higher than 0.022. So according to Cook's distance, we probably have outliers on level 1. For level 2, again, we use the nlme influence function with a fit object, and level now we can't put in level equals 2. That wouldn't work. We have to specify the name of the grouping variable. That is the variable that denotes the level 2 units. In this example, it's subject. And here for all subjects, again, we have Cook's distance. Let's see what the highest values are. 0.157. Is this high? Using again the formula 4 over n. In this case, n is 18 because we have 18 subjects in this study on level 2. 4 over 18 is 0.222. So here there are no outliers according to Cook's distance on level 2. Please note that we don't get Cook's distance separately for random intercept and random slope. Next we will look at the box plot to get a visual understanding of possible outliers. For that we use the nlme resid function from the same package, again with the fit object and the level. And here we get all kinds of residuals and fitted values. There are two kinds of residuals we could use for the outlier analysis. Here the resid and here the ls resid. Resid is a so-called empirical base estimate resulting from the full model estimation. That has the possible disadvantage that level 2 effects and level 2 residuals can influence the estimate of level 1 residuals. For that reason I would prefer the ls residuals. Those are least square residuals, that is, for each level 2 unit, in this example for each person, there will be estimated a separate least square regression. And thus we can't have any influence of level 2 effects on the level 1 residuals if we use ls resid. However, that's only possible if we have a sufficient number of observations for each level 2 unit. Here we have 8 observations per person. At the same time we have only one fixed predictor, so that is sufficient to calculate a separate least square regression for each person. So here we can use ls resid. And now let's look at box plots. Here the ls residuals I'd like to plot, and we want to see those separately per level 2 unit. And looking at the box plots, we can identify some outliers, so we should probably investigate those cases, whether they are legitimate observations or if there is some kind of error or something like that. Then to the level 2 residuals, again using the nlme resid function. sleep fit as a fit object. Level, again, we can't use 2, we have to put in the name of the grouping variable. And for the level 2 residuals, least square doesn't make that much sense, so I don't want to get them here. Here are the level 2 residuals, separately for intercept, rainf, random effect intercept, and rainf days, random effect days, that is the random slope of days. And for those two we can request box plots. Random intercept, here we can see no outliers, that's good. And random slope, here are no outliers as well. So on level 2 we don't have an outlier problem, which corresponds to the results we got with Cook's distance for level 2, where we hadn't any outliers according to Cook's distance. That's it for outlier detection with a multi-level model or linear mixed effects model with R. Thanks for watching and see you in the next video.